Before healthcare solutions are distributed globally, we need to know that they will be affordable and accessible to all. Before producing therapies in the millions, we need to be confident that we will not harm the planet. Before the industry meets a new challenge, we need to be sure that our ethical practices can sustain our business. Sustainable pharmaceutical manufacturing needs the right start. The right strategy for sustainable manufacturing outcomes starts with the virtual twin, powered by science. The virtual twin experience fosters sustainable innovation in the best interests of society, the environment, and business. Start your sustainable pharmaceutical manufacturing journey with the 3D Experience platform.
Hello and welcome to Two Heads Are Better Than One, Accelerating Sustainability Through Virtual Twin Technology. I'm Kenneth Cukier. I'm a senior editor at The Economist and the host of the Babbage podcast, and I'll be moderating today's discussion. So first, I'd like to thank you for listening and being a part of this. I'd like to thank our sponsor, Dassault Systems, without whom this event would not be possible. And I'd also like to thank, of course, our speakers. I'm delighted to welcome them now. The first is Florence Verzelen, the Executive Vice President for Industry, Field Marketing, and Sustainability at Dassault Systems. Louise Neves, the Chief Executive of GESI, the Global Enabling Sustainability Initiative. And thirdly is Bish Sen, the Executive Vice President of Supply Chain at Unilever. Now, also with us is Nigel Stacey, and although he is going to be listening to the panel, he will be joining me at the end of the panel to talk about the key takeaways. Now, Nigel Stacey is the Industry X Global Lead at Accenture, and for the first 45 minutes, I'll be in discussion with Florence, Louise, and Bish, and Nigel will join me to discuss at the end in a one-to-one interview what we hear. Now, to get underway, let me start and pose the question, well, virtual twin technology, virtual twins. Wait a minute, virtual twins, really? Is this old or is this new? Because, of course, the idea of conjuring up counterfactuals and testing them and thinking them through and coming up with new ways of doing things based on the imagination is certainly as old as Galileo and as Da Vinci, if you look at their notebooks and the structure of how they performed their experiments. So is this new or old? To focus and sort of crystallize the debate, what I'm going to do very unfairly right now is I'm going to pose that to all of the panelists, and I want just simply a one-word answer from you, whether it is old or it is new. And we'll sort of develop it from there and sort of try to understand this. So one-word answer, only one-word answer, old or new, and why don't I choose you, Luis, first to go for it. So Luis, old or new?
I was saying old.
Old, very good. Florence?
I will say innovative. Neither old nor new.
So there's always a rule breaker. There's always a rule breaker. Bish, new or old?
Very new.
Very new. So we've got old, very new, and innovative. Now I'm completely lost. So Florence, you're going to have to help me out here. Why did you not choose my very simple instructions of being binary, black and white, old or new? Why did you come up with a third way?
I think because it was a simplistic view, old or new. We've indeed did make mock-up like since years, since decades, since centuries before doing things, but being able to do digital mock-up where you can indeed be multi-scale, multi-physics, use the latest rules of physics, of biology, and insert them in your mock-up so that when you simulate what's going to happen to a human body, to a city, if a tsunami happened to a city, you see what's actually going to happen to a building. That's very innovative and that's very new because we've never had the power of technology to do it at such a scale till now.
Okay, so I see that it's innovative, but let's actually unpack the old versus new, because I think that'll affect how we can imagine how it's going to be implemented and the impact it'll have. So very new. Bish, make the case why this is actually radically new, never seen before.
So, before answering that question, I'd like to unpack what a virtual twin is. So, virtual twin is essentially let's say, a group or a bundle of algorithms that rely on that have three unique characteristics. Number one, they mimic and predict the physical conditions or the conditions of a set of physical assets or a set of physical operations or happening on ground. Second, they're fed by real-time data streaming from either from sensors or from ground truth sources. And number three, they have the ability to take prescriptive action based on what they predict. Now, so while models have been around for a very long time, the ability to mimic and predict in real time is very recent because we didn't have the computing power and the bandwidth to do it before. And number three, we have never been able to use them to take corrective action in a cognitive learning manner. That, for me, the differentiator is a cognitive part of it. That's very, very new.
I'm going to come back to the cognitive learning manner in a moment, but let's first hear from Luis on why he accepts the very reasonable position that, in fact, this is old.
Well, I'm a little bit radical when it comes to technology. What we have been seeing is that technology is moving at the pace of the light, so everything is moving very, very fast. And I've been in this world of telecommunications and digital. You can look at me; I'm already in my 60s, and I started in telecommunications at 17. What I've been seeing is that transformational change in digital happens very, very fast, and what is new today is old tomorrow. And although I do agree that we're talking here, let's say from a technology perspective, let's say digital twins is now very much on the spotlight, but we have been listening to about this technology since a couple of months, years before. And for me, months in technology sometimes is already, when I look back, it's already old. So our digital is very transformative, it's changing all the time. Of course, I do understand the points from Bish and from Florence, but I also wanted to be a bit provocative in this conversation, as we need to understand that when it comes to digital, we will be seeing things happening faster and faster. And so what is a good technology today might no longer be a good technology tomorrow because things are changing very fast.
So let me ask, do you agree with Bish's definition of what a virtual twin is? I do actually think that the way that he's defined it, he actually has focused on very clearly on what is new with this technology. And if it's new, it therefore might be innovative and it produces innovations as well for Florence. But let's first ask, do you agree with Bish's definition or would you add anything?
No, I would not add anything. I think it was a very clear definition.
Florence, how about you?
Yeah, I think I will add virtual twins are particularly useful for simulation purposes, not only to follow the real time, what's happening on real time, but also to simulate the future, what's going to happen to the product, to the manufacturing plant in the future, and what's going to be the impact for the planet. That's what's super important about the virtual twin, and that's the ability that virtual twin can bring to all of us, meaning doing multiple simulation of the virtual twin before deciding what you actually want to do in reality.
Okay, so tell me how it works. And if you want, maybe it'll be easier to tell me how it works with an example, either one that you've actually in practice put into place, or one that you see as sort of a canonical example that will, clear the mind and be a vision of what's to play for, the sort of thing that will be possible once we actually build the system.
Yeah.
But Bish, why don't I, since you started us off, I'll have Bish, why don't you go first and then the others can jump in.
So I'll give you two sets of examples. So we are using virtual twins today to run. So let me wheel back. Unilever makes laundry powders, and laundry powders are made in very large spray drying towers where you pump a slurry at a high temperature, it comes in contact with air, and it produces a powder. We're using virtual twins of the tower to literally control and run the tower. We've been doing this for a while. This was actually this was tested out during COVID times when we couldn't get people onto our sites because of COVID restrictions. And we actually had the twin running the tower, and interestingly running it better than humans can, with a 15% reduction in energy consumption. So that's one example, and we've now got a fair few of these across our factories, not just for powders, but for other applications as well. The second one that we're doing is we're working with two different startups to, in real time, predict where deforestation is beginning to happen on the ground. So and where it's about being able to predict where deforestation is going to happen, and then picking that up in real time and saying that this is where it started. So these are two real life examples.
Before I go to the others, let me ask a question about this. That is just so interesting that you're doing it for these two use cases. One, which is pure business, right, is actually what you do. You make laundry soap, you're making laundry soap better. The other one is deforestation, is about the sort of a corporate goal that's adjacent to the actual business of operating a large conglomerate that you, or multinational that you do. How did the organization go into virtual twin technology? Who sort of signed the check to do it? Who had the vision to get the whole organization to implement it? And then I'm going to go back to other use cases with Louise and Florence. But to you, Bish, how organizationally did that get situated?
So it started off as a very small pilot to test out the technology on some of our manufacturing processes in Brazil. And it was actually it was not a very substantial investment in it. So it was part of my budget. It was part of my remit. I was exploring different kinds of different ways of doing, literally talking about the factory of the future. And then we started experimenting with it. And that was about 2 years ago.
Did you have the same title? Were you still? So did you have the same title? Were you still a supply chain guy at the time, or were you doing something else?
Same time. And the job was about inventing the supply chain of the future. So the question asked of me is, what's the supply chain of the future? And we were trying out various kinds of applications. This was one of them. We tested it out in a manufacturing application. We saw the benefits that come out of it. And we've been since rolling it out across different manufacturing streams. And at some point in time, it then became, the question was that if you can make a twin of physical processes, how difficult would it be to make a twin of the planetary processes? How easy or difficult is it to think of a twin of the planet? And that is where the deforestation application came from.
Okay, really interesting. Florence, how about you? What have you done, or what is your vision that'll help us explain how virtual twin technology works?
Well, let me give you an example, and the example is a company called Eviation. What do? They are working on building an electric plane, a 9-seat electric plane, with the idea that with an electric plane, the carbon emission will be close to zero, and that the cost of the plane could also be 90% lower. So they're basically building it in the virtual world with 160 suppliers. And the way they're doing it, they're an Israeli company, and the suppliers are all over the planet, is really each of the supplier is building his piece of the virtual plane in the virtual world. And then they're doing all the tests, including the crash test, including the airflow test in the virtual world. So they are very quick to go to market, and they are really quick to do the first prototype. And guess what? It's working, and the plane is going to be produced in 2022. And that's just one example, but we have other examples like Natesco. What do they do? Wind turbine. And what's the challenge for wind turbine? It's efficiency and how long they are going to be in place and working. So they did the same thing. They basically designed their wind turbine in the virtual world, and they looked at what kind of event could happen to that wind turbine, torpedoes or whatever, and what will be the impact, so that they could design the best possible design before implementing it in reality. So that's really the purpose of virtual twin, taking the best decision and then later on using the virtual twin to maintain and do predictive maintenance and make sure that the life of the plane of the wind turbine is as long as possible.
Okay, good. Louise, I want you to come in on this and let me know. I'm trying to figure out, well, how does it work, and maybe use an example to sort of clarify the mind.
So let's say 2 or 3 examples from my side. And so one that it's coming from Ericsson, which collaborated with the port of Livorno in Italy to deploy digital twins along with the cloud technology to improve logistics in the port. And this solution really led to, let's say, an efficiency in CO2 emissions, which dropped around 10%, derived from a lower fuel consumption. Let's say another example that comes to my mind, it's the Google DeepMind, which uses digital twins and artificial intelligence to cool data centers. And this is an extremely efficient solution. Google achieved a 40% reduction in energy used for cooling, meaning a 15% reduction in overall power consumption. So, these 2 examples to add on to the others that were already explained by Bish and by Florence.
Sure. I mean, the interesting thing that, because you bring up the Google DeepMind, server farm and the energy reduction that they were able to get from it by sort of applying deep learning and other artificial intelligence approaches to it. But the interesting thing there is they were generating a model, but it's a model of virtual twin. I mean, it seems like if any model is simply a virtual twin, then everything. The virtual twins have been with us forever. I have a feeling I think it's different. I think that a virtual twin technology isn't a model. Actually, going back to what Bish says, it is actually allowing for you to actually, a model is just simply, obviously, a model, a representation of a phenomenon in the real world that you can test. But a virtual twin is one that by testing it, you can iterate it, and it can constantly update what you are actually testing, and it becomes something new. You'll actually learn new information by posing new counterfactuals to it. Let me actually maybe go on this thread, because it presumes in all of your examples that you can actually generate an adequate model of the real world, that the virtual twin looks like the ground truth that you're trying to control for, adapt for, and build for. And I imagine that's really hard to do. Is it?
Well, I do not have an answer to that. Maybe Florence and Bish, they have a better answer, as they are more deeply involved in these technologies as I am.
Yeah, well, if I may, yes, it's very hard. You need a lot of technology and you need a lot of science. So the way we do it at Dassault Systèmes is we are specialized in artificial intelligence, but also in biology, but also in computer-assisted design, in subsurface, and in each of this domain, we are constantly implementing the latest laws of physics into our software. So as whenever you design an house or a living heart or a brain, you have what's the most accurate state of science when you design your brain. So you have to constantly improve with all the research and development that's being done, and in order to have the most accurate model. And of course, you also learn from your virtual twin, because if you do the virtual twin of my brain and it doesn't react, and you put electrodes and it doesn't react back. My virtual twin brain, then you can see there is a problem and then you can do some more research. But it's basically a big area of research. And depending on what you want to do, you don't have the same kind of accuracy. For the human being, we have less information because we are not as advanced in terms of R&D. That's what we are able to do when we model a plane, material science, or just like housing and biomaterials.
So the interesting thing here is that by modeling things so well, by creating a virtual twin, we can simply do what we're already doing better, but we can add these new goals, these new values into what we're creating that were harder to do before. So the climate is a complex system. Questions of emissions are very complex. We were actually creating virtual twin technologies before when we didn't have the bandwidth and the processing power and the computing and the algorithms. Now that we're doing it, we're not just simply applying it to making soap powder better, but we're actually applying it to saving the world. Tell me more about that. The sustainability element of that seems like a really important play.
So, Ken, before we jump onto that, I want to just hark back to your earlier question, because I think that was a really great question about the model, the difference between a model and a twin. So in the past, we've always started off with a hypothesis or a deterministic point of view about what the model should be like. So, and therefore models are centuries old, possibly. And that's what, when I was in university, that's what we learned about how to describe a process or any kind of activity. The difference today is that we do not need to start with a definitive hypothesis. And in fact, we are at a point today where we have algorithms writing algorithms. And I think that's the big unlock. That's a big shift. So I have a complex, multivariate process happening. And instead of agonizing over trying to form a deterministic point of view before I start modeling, before I start creating anything, as long as I have disparate sets of data in different forms, you can then start letting the algorithms write the algorithms to define them, to create the model. That to me is a big shift. And to go back and to answer to your question now about the emissions and the planet, yes, as long as we can define a problem, and we can define and start identifying the data sets which we think might go with it, no matter how uncorrelated they might appear at first glance. I think there is sufficient mathematical power and computing power available today to be able to start crystallizing or to start crafting twins based on that. And the best part of it is that the twins learn as they go along. So the twin literally grows in cognitive capabilities as it ingests more data, as it sees under what conditions the deviations happen, where do the failures happen, so two big things, where are the patterns and where are the failures? And I think the more it learns, the more intelligent it becomes. That's a big difference.
Okay, this is deeply interesting. So, Florence, I just want to go back to this before I go to you, which is to say, it's so interesting, but it's clear that the term twin is actually a metaphor, and it's the wrong metaphor, because it suggests a clone, that you have this offline thing, and now you have this real thing, the territory. You have this map, this model that is a simulacrum of it, and you have a one-to-one correspondence. But what you're saying is that this thing, the simulation, becomes smarter. So it's not a clone or a twin, but it's something else. And we don't know what that term is for it yet. But as you say, I mean, that's very intellectually ambitious. And it goes back to what your earlier point about the sort of cognitive change that will be generated by the virtual twin technology. Let's come back to this before we end our session, because it is so deeply interesting. But Florence, I cut you off, please.
Yeah, no, definitely. Yeah. It's exactly what you were saying. What's very interesting about the twin is that you can do a lot of simulation of the twin. You're not going to simulate 1,000 scenarios on your planes, but with your twin, before you manufacture your plane, you can simulate which materials you're going to use on which airflows you're gonna create with your air conditioning, and you can decide what are the most sustainable scenarios. And that makes it super interesting because you can know from the beginning, if you choose these materials, how much CO2 you're gonna emit, how long your plane is gonna live, how many kilometers it will be able to do. And that makes the virtual twin a lot more intelligent than just the plane. And if we take the example of like Amcor Rigid products, which are doing packaging, thanks to virtual twin of their packaging, they were able to reduce the use of material by 50%, which is just huge in terms of sustainability.
It's interesting. As you say, we probably won't do thousands of simulations for a plane. I can only agree with you. Why would you stop at thousands when you could do tens or hundreds of thousands of simulations of a plane?
Exactly.
It's to say that, yeah, that the world is complex. There's lots of unknowns. I think we can all agree that we live in a local optima, and we never know if we've reached a global optima. But if we expand the search space of our query, whether it is to create better materials, whether it's to create lighter structures, whether it's to create better soap powder, whether it is to prevent deforestation, we get closer to by searching more in the problem space to interesting answers. Louise, you've been thinking a lot about these technologies when it comes to sustainability initiatives. When you look at what's happening, what do you see as the most promising area that virtual twin technology is going into, and where it's going to make the biggest impact?
I'm coming back to my first reply to your question when I said digital twins are old, and I explained by that time, and listening now to Florence and to Bish, they were mentioned how these technologies evolve and become more intelligent, and they will continue to evolve. So we're living in a world where technology is and I repeat myself, developing at the pace of the light. And we are seeing developments that in many cases only a few people understand them. Those that are more connected with in the scientific world and more technology driven persons, the most of the world does not understand what's going on and what is happening, and that's why it's also so difficult for many people to also to adapt. And I also come to, let's say, to the regulatory standpoint when it comes to technology. So one of the things that I see as we are evolving and technologies are developing, one positive aspect or very positive aspect is that technology is fundamental for make this world more sustainable. Every single piece of research that we have done in Jesse points to that direction. We have been doing research since 2006 to 2007 around the role of digital and sustainable development. And the more research we do, the bigger the impacts are. That's a clear outcome of our SMART reports and the latest digital with purpose report. The other thing that we are seeing is that as these technologies evolve, we are facing new challenges as well. And those challenges are multi challenges. So we are seeing more challenges in the area of privacy and security and data privacy and security. We are seeing more issues related to other aspects like climate, energy consumption. Although here digital twins are a very good help of that area, so they will help us to address those challenges. But we need to understand that as the world is evolving and technology is evolving, and we are seeing more and stronger developments in this area, that we need not only to speak about the goods, we also need to understand what are the negative impacts of these technologies. And while I'm very positive about the technological development and technology development, and as I said, I see technology as a key driver for a sustainable world, and I'm deeply convinced about that. But I'm also a great believer that as these technologies evolve, we need to pay attention to the negative aspects. Otherwise, we will have a pushback from the policy side and also from people in relation to these developments.
Yeah, I would definitely agree with that. I do wonder though, are there any negatives to the to virtual twin technology? I see that there's these well understood pathologies of online culture, whether email makes us working all the time or that our online systems are vulnerable to hacking, just like offline systems have been vulnerable to fraud and criminal activity. But is there anything unique about virtual twin technology that makes us that we should be tugging on our chin?
So, it's a journey. It's a journey. If you think about it, and we talk about it as most industrial processes started off with the human in the loop. You then move into the next step, which is the human on the loop, and then the final state is the human out of the loop. Now, as the human goes out of the loop, and if I give you a car analogy, it's the human in the loop is driving a conventional car. The human on the loop is like driving a Tesla, which is assisted driving. Human out of the loop is the autonomous vehicle. Now, just imagine that happening across the wider spectrum of industry, happening across the wider spectrum of the economy. As we let machines take more and more decisions, we need to redefine the role of the human. And the role of the human has to be focused on innovation. It has to be focused on managing and dealing with the exceptions, and it has to evolve from the current state of the human doing the task to being the human out of the loop. And I think that's a massive change. It's a societal change. It has a severe economic impact. It requires a complete level of reskilling and of the workforce. And I think it's almost a reinvention of the role of the human in the industrial framework.
I think that's absolutely right, and it does present all those changes. But what's really to play for? I mean, I want to focus on the more optimistic element of that by sort of taking the point and doing a jujitsu move on it, is to say that that's true, but that there's a static nature to what you're saying, and which is we've done X, and now we actually are applying these technologies, and now it does X, and that's true, it will, but the technologies will also be able to do A, B, C, D, E, F, G, which it wasn't doing before. So we're not just doing X, we're doing all of these new things. So I'm very optimistic about what's the benefits of it. And also I think for employees' work and satisfaction of work, I'm also optimistic as well. So to think about how we are going to be able to do new things that we never could imagine doing before, I want to go to one of the questions that we've received from our viewers and from the audience. And so one of the audience questions has been, do you see virtual twins being used to create models that can predict the extent and sources of environmental damage and then assign monetary values to them? So what I think is so interesting about this is that you create software, you set it as a default setting, and suddenly you get these great virtues, these great benefits out of it by dint of just using behavioral psychology of a default setting and putting it into software. You get these scale effects, and that's so interesting. But imagine that you have the virtual twin technology and a spreadsheet, and suddenly not only are you playing and optimizing for efficiency, but you're also looking and optimizing for sustainability with a dollar sign next to it. Suddenly it becomes a game changer. I mean, I think that's a very fascinating way and a new way of looking at the world through the lens of virtual twin technology that's enabled by these digital tools. So I'm now going on a flight of fancy, I realize, based on the viewer's question, but who would like to take this?
I'd like to take it.
Sorry, go on, Florence.
Florence first and then Bish. Good.
Thank you, Bish. Well, just to tell you that that's exactly what we've looked at together with Accenture in a study we did on virtual twin and sustainability. And what was the study about? It was using 5 use cases, using a eco-design for building, or using virtual twin to accelerate electric cars, we could see that in just 5 use cases, we could save 7.5 gigaton of CO2 over the next decade with these 5 use cases of use of virtual twins. And that's the equivalent of 1 year of emission for the transportation sector. So this is just huge if we indeed adopt this technology. So totally game changing for the climate change issue.
So, if I may respond to that, so it's not about putting a dollar sign on the spreadsheet, because that's easy. Let's take it one step forward, saying the engine makes the correction, and that's what is happening today. So when I talk about the towers, the spray drying towers, or when I talk about the other operations, if you take your hands off the wheel in a human out of the loop situation, the engine not just estimates what the impact is, the engine makes the decision and writes it back into the system and actually drives it. And effectively what we are moving from is we are moving from a situation where a human looks at a dashboard and makes a decision to the engine making the decision and the human looking at a log of the decisions that have been made. So it's not a flight of fancy, Kevin. I think it's very it's happening now, actually.
You make a liaison between virtual twin technology and automation that isn't obvious. Why? So let me just probe that a bit more. Why should virtual twin technology sort of lead to automation rather than having a human being looking at things and then adjusting knobs and levers?
So if the human, it still adds value after the twin has. There are cases where you might want the human to still filter it or add value to it. And I guess, there will be 20% of applications where the human is still required. But interestingly, where the reason why I see automation as a big fallout of this is because the sheer number of inputs that need to be considered, the sheer frequency at which these inputs need to be dealt with, the sheer volume of computation that needs to happen, it is better done by the machine, with the human being able to audit what the machine has done at a later date, should it be required, rather than interfere with it in the flow of it. So where there is no pattern, where it is not predictable, the human is still required.
It can't be the audit. It's got to be something else. It's got to be creativity, imagination, and the reason why is that
that's of course innovation, of course.
Yeah, I mean, but the point is that it's going to be so complicated that the human can't serve as an audit other than a common sense audit, because the machine is going to be able to do things that will surpass our abilities, in the same way that Louise pointed out that DeepMind was able to actually save 40% of its energy at one of its power of its data center facilities, simply by doing things that no human mind would have thought to do, but the algorithm said it should be done this way, and of course got those gains.
If I may somehow step back here, in coming to your previous question, we're talking, about a world that, as I said before, many people does not understand. I'll give you an example, and I'm coming back to something that Florence said, which I do believe that's true, and it's on the report made by Accenture and Dassault on the let's say carbon efficiency generated by digital twins, and we have done in just many of those reports. The latest one was pointing out that technology can reduce 20% of the global emissions, where digital twins of course are included. So 20% of the global emissions is a lot. So actually we could start to bring down the trend of growing emissions through digital. The point and the problem that we have, we as people that is deep inside these conversations, we are truly believers of these potentials, but those that make decisions, they are not aware of this. And this conversation is outside of the policy environment, and that will damage business and business development as well. Think about the climate convention on that takes place every year, and this year will take place in Glasgow. You do not see policymakers considering technology as a key driver of lowering emissions. So you do not see any discussion about technology in that fora. So that means either they do not understand the technology or either they consider it irrelevant. So if that happens and that continues to happen, we have a problem because that will slow down, that will undermine the pace of technological development, and that will undermine business. So we have a problem in ensuring that people, generally speaking, from the policy side and also the common citizen, they do understand and they do trust the technology and its potential because that's what will guarantee the uptake.
I think that's well spoken. Maybe I'm just too optimistic, but I can't imagine that companies won't adopt this because it's just so fundamentally commonsensical that you can't really manage a complex operation without a digital twin, whether the problem is an algorithmic problem and you're simulating, for example, how a supply chain works or how you manage your HR across multiple facilities, or it's a physical problem like how to make soap powder or how to manage the lighting and the power consumption of a data center. But I could also imagine a world in which there's a regulatory element to it. There's a compliance element to it. You can't be a bank unless you have a digital twin, right? The whole point about stress testing globally as systemically important financial institutions is that you are creating a virtual twin of your bank so that you can stress test it. And what's happening there, you can imagine going into big tech, right? And it's going into all different companies at all different levels. Soon Microsoft or Salesforce is just going to bung it in, or Dassault Systems will just bung it into the software that you have. So I've got Gmail for my email address, and I've got whatever I have for my virtual twin technology. And suddenly I can actually manage my operation in a way that I couldn't manage it before, not because I don't know how to figure things out, but because I want to test and try out 10,000 ideas, some which my smart employees come up with, and then a generative algorithm, a machine learning algorithm, just simply evolutionary algorithm, as we call it in the biz, just goes off and sort of probes different ways, and I can actually identify new things. So I actually see it optimistically that in fact there'll be almost like a regulatory obligation to have a virtual twin technology for everything that we do. It's going to be hard to substantiate that you exercised your duty of care to build a bridge or to manage your HR system if you don't actually have a virtual twin there that told you that, in fact, the answer that you thought was the right answer was the best answer.
So couldn't agree more with you, Ken. I think ultimately, as the application of this technology goes wider and deeper, it will lead to an exponential change of productivity, of human productivity and human creativity, more importantly. The problems that have thus far been too difficult to solve will become, or have already started becoming, they're within the grasp of being solved. So I see it as an enormous unlock for human creativity and for human productivity.
I couldn't agree more with Beige. But what I can see on the market is that the rate of adoption is different from one industry to the other. Aerospace and defense has really been the first, and then there have been the car manufacturer, the boat manufacturer, and now we're really entering the CPGR, consumer packaged goods retail. Infrastructure sector is taking more time. Virtual twin of cities, of bridge, of construction work are taking more time to be really adopted because these are industries that are a lot more conservative. And the skills of the people of this industry were not so digital until now. So depending on the sector, this is going to take more and less time.
I think I think it might take time, but I think the direction of travel is I personally think is preordained. I know that surgeons in Massachusetts are actually operating 10, 20, 30 times on a mannequin, on a simulated, part of the organ, so that they can actually, do the operation, for so to speak, 8 times and cut only once when it really matters. And although they do it right now for high-end surgeries that are a little bit rare and atypical, they're going to be doing it a lot more. I think there's going to be a more commonplace way in which we actually think about how we manage our companies and in fact manage our societies, because there's no reason that we stop when it comes to business and sustainability. We can see that we might be doing it in terms of how we manage government. God forbid government should actually look for what is the global optimum rather than the local optimum. There's clearly a lot to think about, and the conversation is going to be going on for a long time as these technologies get implemented. So let me first thank and wrap up the panel by thanking everyone for joining us right now, virtually, of course. So they are Florence Verzalen, the Executive Vice President for Industry, Field Marketing, and Sustainability at Dassault Systems; Louise Neves, the Chief Executive of GESI, the Global Enabling Sustainability Initiative; and Bish Sen, the Executive Vice President of Supply Chain at Unilever. Now, as we say goodbye, sadly, to our panelists, we're going to move to Nigel Stacey and have a discussion with him about the key takeaways of the panel we just heard. So Nigel, again, is the Industry X Global Lead at Accenture. And Nigel, this has been extraordinary. Wow. What do you think?
Wow. Yes, wow, indeed, Ken. Fascinating conversation. I was listening with great interest, and I kind of wrote down a couple of, I think, key things that we should just elevate up a little bit, given the richness of the conversation. Digital twins and the power of simulation. I think one of the things that really struck me, and we see day to day, is, a digital twin is alive. It's learning in real time. It's constantly adapting. And that makes the technology so unbelievably exciting, because it can truly solve highly, highly complex problems. So when we take the issues such as sustainability, and how do we really tackle that at a corporate, at an industry level, digital twins are one of the ways that we're now beginning to address these complex and critical issues. And as I say, the twin is alive, it's learning in real time, it's constantly adapting. And we heard from the panel that, why it's so powerful is because it's fed with so much data. And that data being fed from all of the disparate systems in a corporation can be analyzed, and very clever algorithms, machine learning, cognitive learning can be then utilized to really get deep, deep insights into what's really, really going on. So I think the fact that they're alive was a big takeaway.
I mean, the interesting thing to hear you say that, to pick up on just that element, is that the virtual twin becomes a platform, right? And they didn't actually talk about it that way, but to hear you sort of conceptualize it, it's a platform because I had come into the conversation thinking that the virtual twin was just simply a piece of technology, a standalone item that slotted in to whether your design software or whatever other system that you're running. If your customer resource management system, this is the virtual twin system. It's just something separate, and it's not. It's a platform. You plug in your machine learning algorithms to it. You centralize all of your data into it so that you can actually learn new things. I think that's very powerful and very interesting. Anyway, I cut you off. You were about to say your other key takeaway.
Well, you raised a great point, because I was just going to go on and say, but for me, the second big takeaway to exactly your point is that we shouldn't just talk about a digital twin. What we need to be talking about and elevating the conversation to is the digital thread across the organization. A digital thread, simply put, is lots of digital twins, from design, engineering, in new product introduction, in manufacturing, in the supply chain, in the after sales, but they're connected. And now when you connect multiple digital twins that are being fed with all of this different data, whether it's engineering data, design data, environmental data, customer preference data, whatever the data sources are, which can be both external and internal, you create this seamless digital thread in the organization. Now, the ultimate power of digital twin technology, when you create that digital thread, is now I can truly start to design for sustainability. I can manufacture for sustainability. I can now really think about where I'm going to buy my raw material from with sustainability and responsibility and resiliency in mind, because your entire product and operating value chain, which is how we refer to it within Industry X, is now seamlessly connected. you're simulating hundreds of different scenarios at every point of that digital thread. And that's when the power of digital twins end to end will really impact massively corporations and entire industries to not just realize the value of the technology, but make then intelligent insights into what to do with that data to drive more sustainable products, more sustainable outcomes, more sustainable manufacturing, and a better society and a planet for all. That's the real power.
Now, of course, I can only agree with you when you say that that is the power and that it's to play for. But getting companies to act is always so difficult. How do you get managers and boards of directors to buy into the vision and to actually open up a pocketbook and pay for it? And actually, of course, it's not just about money. It's about redesigning your practices, your operations, your workforce, your reporting structures to enable it.
Yeah, it's the question.
Help me here.
How do you do it? So I think there's three critical things that companies need to do. The first one was your first point. You actually need a vision to start with. You need to align your organization around a clear vision and a strategy as to where you want to go. The second point is that you've got to remove the internal silos that exist historically within corporations. You need to bring your departments, your functions together, align and coalesce around the vision and the strategy that you've laid out. And the third thing that you've got to do is you've got to appoint senior C-suite executives that will then be responsible for driving that strategy, the vision and the strategy throughout the organization. So you really bring the organization together. You're now more of a network rather than functions or departments. You operate as part of a network that has a common goal, and you align, and then you give people the authority to go and deliver.
You know, it's so interesting to hear you say that. I would challenge one thing that Florence had said, in which she said as a joke, like, it's always about money. And the fact is, yeah, I think that's a very 20th century view. I sort of agree with it. You know, it always is about money. That's a classical economic view. But it's really always, it's also always about leadership, right? Because it's the leadership that unlocks the resources. It's the leadership that has the vision. I think that the world is less capital constrained than we think. And it's actually more leadership constrained than we know.
I couldn't agree more. We released a paper just coming up to 12 months ago now with an Industry X about how do you make things better. And we talked about the digital adoption, right? The rates of digital adoption. And what that paper clearly showed was that leadership, the removal of silos, clear accountability, clear alignment from the top of an organization around that common vision and align the entire organization. The companies that do that fundamentally outperform companies that struggle, that still have those silos or don't appoint the right level of seniority. And underpinning all of that, to your point, is change management. The change management process should not be underestimated. The panel talked about, technology, and the human interaction. What we say in Accenture is it's about the promise of technology and human ingenuity. They're not separate, they come together. The power of technology and human ingenuity coming together is absolutely vital as we now accelerate the adoption of digital twins, digital threads, and really get after addressing the most complex problems that faces society today.
Now, we're running out of time, but you have these takeaways for a very interesting panel. So let me ask you, hit me up with just one last one. What is your last takeaway from the panel?
Well, so digital twins are here. Digital threads are here. They're not going away. And I think I will go back to the very first comment that was made around the rate of technological development is increasing at unprecedented rates. The beauty of a digital twin and a digital thread is that it will constantly learn and it will evolve at unprecedented rates. So if there's a technology out there that today's companies should really seriously consider adopting, it is the very essence of digital twins and threads, because they will constantly learn and evolve because they are alive.
That's great. It's fascinating. I think there's definitely a lot to play for, and it'll be interesting to see how it evolves over time. Sadly, that is all the time that we have for the conversation on virtual twins right now. But the good news is that we covered in The Economist, and the good news is that lots of organizations are doing fascinating things about it that we can take a look at. I want to thank you, Nigel, for helping me understand these issues. Of course, I want to thank all of our panelists that we just heard from as well for a fantastic conversation. For me, the biggest takeaway is the cognitive shift that, Nigel, we just spoke about, but also that Bish, Reyes, and that Florence and Louise also invoked in their conversations as well, in their remarks, that as we move forward using these technologies, that, as Nigel, you just said, that it is adaptive, that it's sort of in some ways alive, and that it'll actually change. But it's also not just going to change the real thing that it's actually modeling, it's going to change us as well. We as humans become smarter because we learn something new that we didn't know otherwise. But then again, of course, that's nothing new. Our tools have always shaped us just as we have shaped our tools. That is an axiom of the human story and of the human tragedy, perhaps. But the good news is I think this cognitive shift is a very beneficial one, and one that in terms of sustainability is going to lead to lots of great potential and hopefully lots of great benefits and reforms as well. So once again, let me thank our sponsor, Dassault Systems, for making this possible, and thank all of you for listening. The Economist is proud that we can actually bring you these virtual roundtables, these virtual panels. Also, we're very happy that we can actually produce a weekly publication for you. And so if you're not a subscriber, please do subscribe to The Economist. And if you're not a listener to the Babbage podcast, please listen to Babbage, the podcast that I host on technology each week. Thank you very much for joining us.